This is Dr. Hassan Abdullah with the course Web Applications Programming, and the topic which we are covering is structured query language. And this is topic number 7 in the list of topics of the courses, and the subtopic is 7C. So, in this topic 7C, we will be covering the group by clauses, which is used for count, the average, the minimum, the max, and so on, and some string commands also. It's full text search, basic and advanced, and you can search for the topics or the material of your interest. And if there is any visual disability, the user can set the font size, the color, the line spacing, the type of font to facilitate, to maximize. And the content is displayed and is presented in a nested hierarchical fashion in a manner, and that helps facilitate. For example, you have the bullets, then you have the summary, then you have the explanation of the bullets, and then you have the references and diagrams if needed. And of course, there are online exams also to practice, to know what you have learned, and the system also identifies the weaknesses, and the system tracks your progress, so you know what you have covered, what you have not covered. And of course, it is uh, beneficial, and it has been optimized to work on small devices also, like smartphones, their alignment and everything. So this is all explained in these 6 videos, and these videos are available at this URL, or you can go to YouTube and type my name, Dr. Hassan Abdullah, and it will take you to my official YouTube channel where these videos are available. And the approach of this course is maximizing upon the question and answer based approach, which is very proactive and which is very engaging. Okay, and it promotes thinking, and of course it also capitalizes on the traditional approach where data and facts are presented. So it's the best of the both worlds, which I've explained in the previous slide. So these are the topics which are covered in this course, and we are at topic number 7, which is SQL programming. Okay, and this topic is explained in the form of questions and answers. So this is the list of topics, and we can see that we are at topic number 7. Now this topic number 7 has 20 concepts in the form of questions and answers. So as the color coding shows, the first 5 is in 7A, the next 5 are in 7B, then the next 5 are in 7C, and the last are in 7D. And now we move on to the supplemental website, and there we will look at each of these concepts in the form of questions and answers. So we are at the third set of Q&A for topic 7, that is 7C. So the first 5 Q&A were covered in 7A topic. The next 5 were covered in 7B topic. And now we are at the third set of 5 Q&A, question and answer. So this is topic 7A for SQL programming. So what is MySQL equijoin? Give SQL examples. So MySQL basically is the database, and SQL is the structured query language. So let's look at the example of equijoin. Basically, in equijoin, we compare the matching columns, and only those results are displayed or retrieved which have matching values. But there are fine variations in the equijoin also, which is the types of equijoins. So I will talk about them, and the join example also, so that it becomes clear that why do we need those equijoin, right? So for example, this will be discussed, but in the for example, in the employee table, we have the ID of the department in which an employee is posted or engaged, and then there's a department table where there's a code and the description of the department. So AccuJoin is going to match those codes and give the name, the textual names. And there are types of equijoins, and of course, there are advantages of equijoin which we'll talk about. So let's go into more detail. So we have two or more tables are combined, right? So we limit ourselves to examples which with two tables. Of course, there can be multiple tables also. And the equality condition used is the equality operator, right? So that's the operator on which the matching takes place. And of course, this works. When does it works? When two tables share common values. Okay, and what are those common values? The common values are the foreign keys and the primary keys. Okay, so for example, in the employee table, the department number is going to be the foreign key because there can be multiple people who can be in the same department. But in the department table, the department ID is the primary key because in the department table there are unique departments, and in the employee table the employee number is the primary key because every employee has a unique ID. So there are some we have two Q&As in which this is covered also. So as we mentioned that types of equijoins here. So there is the inner join, which we'll mostly cover. Then is the left join, and then is the right join, and of course there is another one also. So, but the most commonly used is the inner join. All right. So definition I've already discussed with you. So let's look at one example here. So select column. So it can be multiple columns. So select column where from table 1, and inner join with what? Table 2. On what? Table 1 column name and table 2 column name. Since the tables change, so the column doesn't create any confusion because we have table 1 dot column name. So this is the inner join, right? And what will it do? Ensures that only rows, okay, which are equal are included in the final result. So if we look at this example, so we have two tables here. So we have the employees table and we have the departments table, and employees dot name, select employees dot name. So from the employee table select the name. From the departments table select the department underscore name. So that's what it is saying in plain English. On perform an inner join, right? On what? Employees dot department ID. Every employee we are assuming is assigned to a department, and based upon what? Department ID. Which ID? From the departments table. And what will be retrieved from the departments table? Department underscore name. So that's going to be retrieved. So for so what this query is going to generate? It's going to generate a list of employees, the name of employees, and again, and with that employee name will be the name of the department where that employee is assigned or posted. So that's so I would suggest that you type this in your prompt, SQL prompt, and run this query. So different types of equijoins, inner join, which we have just discussed. Left join returns all rows from the left table and the match rows from the right table. Okay. Right join is just like the instead of left with the right. Full join combines the results of both left and right join, returning all rows from the both tables. So that's how advantages of equijoin is to ability to combine related data from different tables. Okay, and of course that it gives a comprehensive information, and it is computationally efficient also, and it is easy to understand as compared to the left join and the right join. And to make it more easy to understand, so I have shown this picture over here, so that makes it the understanding very simple. So we have the inner join. Select asterisk from table T1. Okay, perform the inner join on table T2, and table T2, and on what? Okay, on what? This is the T1 on foreign key, and this is the ID. This ID basically is the primary key. So this is the inner join and left join. So all the rows from the left table, right join all the rows from the right table, and so on. So if you are interested in more, here are the references. Okay, so what are SQL string processing commands? Give examples and explanation. Now these string processing commands are very powerful commands. and they provide a lot of processing uh, capacity and variation on processing of textual data. Okay, and because the data in normalized form, that has certain application domain, and in many domains we are working with a lot of text. For example, processing CVs. For example, processing the activity of log activities, how the website, the web application was being used, or we have reports. So there are a lot of text there. So these basically commands, string processing commands, provide a lot of power, right? And along with this powerful string processing, there is also powerful string processing commands available with PHP also. So this is very powerful. So concatenate, basically, concatenate from its name is apparent. It can appends together textual strings. Substring basically takes out piece of the string. Length gives you the length. Trim removes certain thing. Upper and lower changes the case. Replace, you find for a part of string and replace it with some other, and then you perform the we'll look into it, left and right, and so on. So returns the instr returns the position of the first occurrence of a substring within a string. For example, we this is the statement hello world, and it will return 7, right? First occurrence of the word subs within a string. So what we are looking for? We are looking for world 1, 2, 3, 4, 5, 6, and 7. So it is at location number 7. Left right, basically specified characters from the left or right side of a string. Specified characters. So if you look at these examples, so we what I have here for you is the string command for SQL. Its purpose is example and its explanation. So it's kind of self-explanatory, but they are very powerful, right? So what are SQL wildcard string processing commands? Give example. Now, this is very powerful stuff. We are looking at wildcard means that you are not aware of what you are looking for, but you know part of it or some of it. Some means that not as SUM but SOME. So using this wildcard string processing command, you can do a lot of processing and you can get what you are looking for, but you don't exactly know what you're looking for. So some of these commands are used in topic number 15, which is developing a dynamic web application. So string processing is there. So for example, these wildcard string processing, you can make a very powerful system for an for HR, or for to like shortlisting the CVs. So what are those wildcard string processing commands? So what basically do is basically you don't know the specific string patterns, okay? So but when you have names, descriptions, or addresses, okay, and but you don't know the exact data, then they're very powerful. And then in addition to it, so you use this and this, of course, and then you can define your custom characters. Because say for example, if you're looking for a percent sign, then percent sign is a wildcard, but using escape you can define your own character to be looking for, which is percent. And then is the not operator also, which is the logical inverse of like basically performs inexact matching, okay, when you don't know what you are actually looking for. So these are very powerful wild string. So let's look at some example. Percent sign is select asterisk from users where name. So get all the columns, okay, from table users where name is like J percent, capital J percent. It means that you're looking for the names which start with capital J. And wildcard basically you don't care how many characters follow J. Okay, now you have this underscore. So underscore in quotes now in certain dialects this single quote may be replaced by double quote. It depends upon the version. So what it is saying that select all columns from users table where name like underscore n. It means that you can have anything but a single character to the left of n. So Dan or Jan or Man, and so all those names are going to be filtered out. Escape is you are looking for percent sign. You are looking for AB percent 123, right? Escaping the character percent sign. So otherwise, this percent sign is used as a reserved keyword. But with the escape character, you can use it as a character. You define your own. Not like is the logical converse of not of I'm sorry, logical converse of like. And like basically matches perform partial matches also. So MySQL limit command. MySQL limit is again very useful, especially in pagination, because try to understand that say for example you go to, I would not like to name any specific web portal, but you go to a web portal and say for example it has a billion pages indexed, and assuming for simplicity they are in a tabular format in a database. Now, out of those billion pages, you are only interested in, or you can look at, say, 10 pages at a time. Now, if like everybody starts displaying a billion pages, so their server is going to crash. It will have a lot of load on it. So what limit does is that it controls the number of records which can be displayed, and using the limit you can also do is using the offset. Using the offset, you can also control that how many records should be skipped, right? And then the limit which you had set, 10 or 15, whatever that is displayed. So this is of immense use for pagination. Pagination means that you run a query and your database had say a million records, and out of those million records only you are going to show 10 records per at a time. So that is pagination. So in topic 15 there is a whole exercise on pagination, and you can also do order by clause. So you can say that for the top send show me the last 10 results based upon a certain metric, ordered based upon it in ascending or descending order, or show me the top 10 in ascending order, and so on. So this is very powerful. So basic syntax is the select columns, depends upon how many columns you want, and from where table underscore name. Limit is the number of first 5 rows of a result set. Okay, that's limit. So so this is the generic syntax. This is the actual example. So show me the first 10 rows. And here we are saying that select asterisk from employees, limit 10, offset 20. So skip the first 20 and then show me the next 10, right? So, and of course, so this is basically used for pagination. And select name age from employees table, order by age in descending order, limit 5. So oldest employee by first sorting the employees table by the age column. Okay. So oldest employees descending order. And of course, limit in multiple queries, especially in scenarios like pagination. So that you'll see also. So this is with the offset, only the desired result for return for each page, making it an essential for data retrieval user interfaces which are flexible and which are user friendly. So more details are here. So what is the primary key? Now this we have touched upon in the topic 6, I believe, or databases also. So and give example how the primary key is enforced. So primary key is a unique identifier. So that uniquely identifies a record. So for example, your passport number is a primary key, or national ID card number is a primary key. Vehicle registration number is a primary key. Of course, that primary key could repeat in the world. So for example, your vehicle registration number in country A may be an ID some of other type in some other country. That's possible, but not within the same country. So primary key is a unique identifier, and there is a constraint of uniqueness. So if, say for example, you load data which never had a primary key, you could run into the problem that you may have repeating values. Of course, those repeating values can be identified using SQL, but the that is the uniqueness constraint. And non-null constraint, a primary key cannot be a null value. Okay, and enforcing primary key in SQL. So it's a unique identifier that I have discussed with you, and uniqueness constraint is in not, and it is not null. So when we create a table, then we say create table students, and the student ID is an integer, and that's a primary key, and then the name varchar 100, and age is an integer. So we create a table and we enforce the primary key, and of course you can drop the primary key also, which is shown in topic number 15. You just do a drop primary key, and the primary key is gone. So this is the C panel, and you can see that you can, yeah, if you select this, and you can then make this a primary key, or you run the query and you go to SQL here and run the query, drop primary key, this will be gone. Then you can, using this interface, you can create or assign a primary key to any to a column. And the primary key, the index, the type of index used here, this is index is B tree index. B tree doesn't mean binary. B tree means a balanced tree. So which is very fast technique, and the distance of every leaf to the root is the same in a B tree. So if you're interested in B trees, you can click on top. It will take you to top, and go press the yellow button, and in the yellow search box type B tree, and you will all the details about it. So that is all for 7C. So now we'll move to 7D.